All right, so let's start with our next topic now, which is about rates, conversions, and ratios. Now, the most important thing that we will learn in this topic is conversion factors. Now, this is actually something that I found out about when I actually started teaching SAT. Otherwise, I would use a different approach to solve problems like these, but this is very helpful. Now, let's try to understand what this is. So conversion factors are basically multipliers, so something that you basically multiply with something to convert something from one unit to another. Okay. For example, if you wanted to convert 6 years to months, how would you do that? You know that 1 year has 12 months, right? Generally, you would just multiply that by 12 and get the result, right? Another way to think about that is, you want to convert 6 years to months, right? What's the connection between years and months? 1 year is 12 months. So it's 1 over 12, the ratio is 1 over 12 or 12 over 1, right? One of the two. You write it in such a way that this unit years gets cancelled. Now for years to get cancelled, should you have years in the denominator or numerator? It should be in the denominator here, and months should be in the numerator. So now 12 months correspond to 1 year. Years and years, the units get cancelled, and we are left with 72 months. Okay? Now this might look like an overkill in this case because it's very obvious that 6 years में 72 months होते हैं, but this idea is very useful and you'll understand that in the examples that we see now. This is called a conversion factor. So conversion factor could be 12 months over 1 year. You could also have it as 1 year over 12 months. Okay? Let's take an example. So let's say we have this bicycle manufacturer who can produce 20 bicycles per hour. How many hours would it take to produce 320 bicycles? Now, it's a fairly straightforward problem, right? You could directly say it should be 320 over 20 and that is 16, right? 320 is the total number of bicycles. We can make 20 per hour. So how many hours will we need? 320 divided by 20, that's 16, right? That will be the normal way of approaching this problem. Right? That's the intuitive way of doing this. But if we do this using conversion factors, how do we think about that? So normally what we do is we start from what we have as the starting point or what we want at the end. So we either start from the starting point that's given or the target that we have, the end point that we need. So in this case, for instance, we need 320 bicycles. That's the result. That's the output that we want. Okay? 320 bicycles. We start with that. We say we have 320 bicycles. Now, what's the conversion factor? Conversion factor is 20 bicycles to 1 hour. So it's 20 bicycles to 1 hour. Is that okay? We want to cancel out bicycles. So we want bicycles in the denominator. So we write this as 1 hour over 20 bicycles. Does that make sense? Now, bicycles and bicycles get cancelled. 320 over 20 and the unit is hours. We get 16 hours from that. That's how we use conversion factors. Does that make sense? So we try to cancel out the units essentially by writing those ratios in a way that they get cancelled. Now I'll go back to another example, but keep this in mind when we look at that example. So in order to work with conversion factors, you either begin with some starting constraint. You might have something given, for example, in this case. Let's look at this example first as well, in fact. So this is another example where you can use conversion factors. There's a box that can hold 6 oranges. One box, it can hold 6 oranges. Okay, one box to 6 oranges. That's one conversion factor that we have. Each orange costs 20 cents. This is another conversion factor we have. One orange to 20 cents. Okay. Given a budget of $540. Now that's a constraint that we have. That's the total amount that we have. $540, we cannot exceed that. How many boxes can be filled? So the final result needs to be some number of boxes. Is that okay? Now how do we start? We start with the constraint that we are given, which is $540. Okay, $540. We start from that. Now the problem is, this is given in cents. What's the conversion between cents and dollars? $1 is 100 cents. So you can say $1 to 100 cents. You want to cancel out dollar from here. So you write it the other way around. 100 cents over $1. And what happens is dollar and dollar, that gets cancelled. And this gets converted to cents here. Is that okay? Then we have 1 orange to 20 cents. We need to cancel out cents now. So cents is in the denominator now. Cents and cents, these get cancelled. Is that okay? And now we have the number of oranges. What's the conversion between boxes and oranges? 1 box to 6 oranges. That's what you have here. 1 box to 6 oranges. Oranges and oranges, they get cancelled. What are we left with? We're left with box. That's the unit of the final result that we have. That's the number of boxes. And then the numbers are 540 into 100 divided by 20 divided by 6. And that gives you the final answer. That's 450 boxes. So what you want to do is, you want to multiply by conversion factors that allow you to cancel out units and reach the final unit that we want. In this case, we wanted the number of boxes to be the final unit, and we tried to cancel out all the other units from there. Okay? How do we know where to start? You would have some starting constraint given. For example, in this case, we knew that the total budget is $540. That's how we start. We say $540, that's the starting point. Or sometimes you have some target given that you want to reach. For instance, in the first example that we did, we knew that we wanted to produce 320 bicycles. So we started from there. So you would have some starting constraint, some kind of budget that you have, or some final output that you want. In this case, that's 320. That's where you start from. And then you write down fractions in such a way that the units keep cancelling out. Is that okay? Is the idea clear to everyone? Now, let's try to use that in some other examples. Why do I have this here? चले एक example दोबारा से वो एक follow कर लेते हैं, and then we'll do some more ourselves. A car travels 1 mile in 1 minute and 15 seconds. How many miles can the car travel in 1 hour? How do we start? What's the starting point? We have a constraint given. The time is 1 hour, right? So that's where we are starting from. We can say 1 hour. Okay? Now, they've made it a bit too long. Sometimes we can simplify this a bit as well. For example, it's very obvious 1 hour, and here we have minutes and seconds. We can convert them quite easily. We are used to doing this minute, seconds, hour conversion. So we can do that directly ourselves and do conversion factors. for whatever is left after that. Okay? So this is 1 hour. The final result that we want is in miles. Let's convert the time units to some common unit. 1 hour could be 60 seconds. And 1 minute and 15 seconds is 75 seconds. Is that okay? So we could start from, let's say, 60 seconds. The unit right now is 60 seconds. Is that okay? We know the car travels 1 mile in 75 seconds. How can we write that here? You can say 1 mile, 75 seconds. Seconds and seconds get cancelled out. What are we left with? We're left with miles. What's the result that we get from this? 60 over, okay, I'm sorry, 1 hour is not 60 seconds. Nobody pointed that out. What's 1 hour? That's 60 into 60, 3,600 seconds. That's 3,600 seconds. Okay, so we should have 3,600 seconds here. Seconds and seconds get cancelled out, and we have 3,600 divided by 75. You can calculate that and see what that gives you. That should give you 48 miles. Does that make sense? Any problems? If you're confused, please make sure to ask. This is very helpful. You'll find problems in SAT where you have three-way ratios. You have like 3 different things given and you have multiple ratios. It's very hard to figure them out if you don't understand this. You have other methods of doing them as well, but they're much more time-taking. This is one of the most time-taking questions on SAT. But if you understand conversion factors well, this should really be helpful.
So basically
we have to cancel out, make a chain and try to cancel out the units. Okay? The final result that you want is in miles, right? Miles नहीं cancel करना, उसके अलावा बाकी सब कुछ cancel out करना है. Right?
So can we do a hard question?
Yeah, so we'll do some examples now. So Tom drives at 50 miles per hour. Which expression represents the number of hours it will take to drive 5x miles at this speed? Where do we start?
50 miles per hour.
That's the rate. We start from a constraint or the final target. What are we given? 5x miles is what we need to drive eventually, right? That's a given constraint that we have, or the target that we have. We can start from that. We can say 5x miles. Okay, that's the starting point. Now, what are the conversion factors? Miles per hour, 50 miles per 1 hour. Is that okay? That's one conversion factor. We want number of hours at the end. So final answer has to be in hours. We need to cancel out miles somehow. How do we cancel out miles? How do we write this fraction? We could write this as 1 hour over 50 miles. Miles and miles, they get cancelled, and we have hours left. What's that? 5x over 50 hours, which is
10.
x over 10 hours. Or yeah, 5x over 50. You have this option directly here. That's A. Is that okay? Zaira? Make sense? इस क्वेश्चन की बात कर रहा हूँ, ज़ैनब की बात नहीं कर रहा, वो समझ आई कि नहीं? पहले आता है जी, आप क्या करें? करते हैं, थोड़ा सा सब्र करेंगे. अच्छा, let's have a look at this. So this person prints booklets with P pages per booklet. P pages per booklet. Every 5 pages cost C cents and he spends D dollars. How many booklets did he print in terms of B, C, and D? Take a minute, everyone, try to do this. Gee, how do we think of this? The final answer has to be number of booklets. That's what the final unit has to be, number of booklets, right? Now, what are the rates given? P pages per booklet, right? P pages to 1 booklet. That's one rate that's given. One conversion factor that's given. Every 5 pages cost C cents. That's another conversion factor. 5 pages, C cents. And he spends D dollars. That's a constraint that you're given. The starting point, this is where you start from, D dollars. Right? Let's write that down. D dollars. Now, first of all, the other information is in cents. Do we know the conversion ratio between cents and dollars? 1 to 100 or 100 to 1. We need to cancel out dollars. So dollars should be in the denominator. That means $1 to 100 cents. Okay. So this will convert to cents because dollar and dollar gets cancelled. Is that okay? Now we want to cancel out cents as well. Cents किस conversion factor में आ रहा है? 5 pages to C cents. So now we can say 5 pages to C cents. Cents and cents get cancelled. And now we have pages. We want booklet at the end, right? P pages per booklet. Pages we want in the denominator, right? ताकि वो cancel out हो जाए. Booklet is what we want in the numerator. P pages per booklet, that means 1 booklet, P pages. Pages and pages, they get cancelled out. And we're left with booklet at the end. Okay? Now just simplify this. D into 100 into 5. What are the numbers? Numbers are 100 and 5. That's 500. In the numerator, we also have D. So 500D divided by CP. And that's option B. Yes. You'll have some starting point, some constraint that is given. In this case, you were given that he spends D dollars. This is not a conversion factor. So you'll have one figure that's not a conversion factor. He is spending D dollars. That's a constraint that you have, right? That he is only spending D dollars, ज़्यादा नहीं spend कर सकते. So that's where you start. Or you might have some final target given. Like in another example that we did earlier. We wanted to produce 320 bicycles. That's a final target that we have. That's also not a conversion factor. So we start from that. 320 bicycles. और फिर हमने units cancel out करके इस तरह से eventual result पे पहुंचे. Is this all right? No problems? Okay, let's try this now. A certain beach has an area of 87,000 something square feet. What's the area in square meters of this beach? 1 meter is equal to 3.28 feet. Now you can do it without conversion factors as well. It's pretty straightforward. But if you were to use conversion factors, how do you use them? Area is 87,402 square feet. That's the area that's given. You want the final result to be in square meters. So you want meter square at the end. Feet cancel karna hai. What do you multiply it by? 3.28 feet in the denominator, 1 meter in the numerator, right? That's the conversion factor that you're given, 1 meter to 3.28 feet. Is that okay? But the problem is, this is feet squared and this is just feet. So we need to have a square here on this rate. Does that make sense? So feet square and feet square, they will get cancelled out. And we are left with 87412 divided by 3.28 square meter square. You can just put this on your calculator now and you get the result. What do you get from this? Feet square and this feet square, that gets cancelled out. What's the result that you get? Sorry? You don't get any of the options? That's 8.25, right? That's B. Okay? Let's move on. The speed of an object is 210 inches per second. What's the speed in feet per minute? 1 foot is 12 inches. How do you think about this? 210 inches per second for 1 second, right? You want to convert it to feet per minute. Inches bhi cancel karna hai, second bhi cancel karna hai. What's the conversion between seconds and minutes, first of all? And we can start from there. 60 seconds. Remember, seconds cancel out karne. 60 seconds to 1 minute. Seconds and seconds, they get cancelled out. Okay, we have minute now. We also need to cancel out inches. What's the conversion between inches and feet? Inches needs to be in the denominator now for it to cancel out. So we have 1 foot over 12 inches. Inches and inches, they get cancelled out. And now we have foot per minute. 210 times 60 divided by 12. That's 210 into 5, which is 1050 feet per minute. And that should be C. Does that make sense? Yes. Okay? All right. So that's about conversion factors. Need to keep. You should remember how to use this. It's extremely helpful in some more complicated cases like this one, for instance. Iska bahut fayda hota hai. Okay. Now, a couple of very straightforward things. Sometimes you have to find average rate of change. average rate of change. Let's take an example. Let's say there's a rocket that has 360 gallons of fuel after 2 hours of flight and 100 gallons after 6 hours. On average, how many gallons of fuel does the rocket burn per hour? How do you think of this? How many gallons are being used in total? 360 minus 100, that's the number of gallons used. That's what your numerator is. How much time has passed? 2 hours to 6 hours. What's the time duration? 6 minus 2, 4 hours. So you have used 260 gallons in 4 hours. What's the rate? That's 65 gallons per hour. Okay. The previous examples that we were doing, we had the rate given and we had to find some missing information. Now we have everything else given and we have to find the rate. This is an easier type of problem. You just find the change in both values and divide them. That gives you the rate. Is that okay? Any problem with this? Then you have ratios. Again, something that you're already familiar with, but sometimes you get 3 ratios. That's one thing that I want to explain quickly. Ratios generally compare 2 quantities, but it can be more than 2 as well. If it's 2 quantities, you can write the ratio as a fraction as well. So for instance, if the ratio of cars to trucks in a parking lot is 5:2, that's equivalent to saying 5 cars to 2 trucks. You can write that as a fraction as well. 5:2 or 5/2, right? You can think of it both ways. And just like fractions, if you have 5/2, that's the same thing as 10/4 or 15/6. The ratios are also equivalent like this. 5:2 is the same thing as 10/4 or 15/6 and so on, right? Now, what if you have 3 ratios given or 3 different things that are connected using some ratios? For instance, this person bought croissants and what's this? ये क्या होता है? Does anyone know ये क्या होता है? Bagels? क्या होता है?
Basically, it's like dough, and then you boil it, and then you bake it. And then
Okay.
you sell it.
It's a donut without the frosting.
Yeah.
It's a donut without the okay. All right. Thanks. अच्छा ठीक है. How many croissants did she buy? How do we know this? How do you figure this out? This ratio is 3:4. So 3 croissants to 4 bagels, right? Using conversion factor the other way. She bought 72 bagels. Again, you can think of it like this. These 2 things get cancelled out and you're left with the number of croissants, right? Fairly straightforward. But what if you have ratios like this instead? Sometimes you have to combine ratios. Let's look at this example. So this person is following a recipe for a seasoning blend that requires sea salt, black pepper, and paprika. The ratio of sea salt to black pepper is 1:2. Sea salt and black pepper के ratio दी हुई है. And then you have the ratio of black pepper to paprika, that's 4:3. How many grams of paprika should she or he use for 108 grams of the seasoning blend? How do we think of this? Now you have 3 quantities, you have ratios given between the first 2 and the last 2. How do you connect those ratios? बस 7 लिखते हैं उसको connect हो जाएंगे. Sea salt, then you have black pepper. and paprika. Now we know the ratio between sea salt and black pepper, that's 1:2. And the ratio between black pepper and paprika is 4:3. So if we want to combine all of them, if we want to combine all the three ratios, black pepper is what can connect them, right? Black pepper is the common thing between those two ratios. We can make this number the same. So if this ratio is 1:2, we can also write this as 2:4. And now we can connect all three ratios. We can say the complete ratio is 2:4:3. So when you have to connect multiple ratios, you look at what is common between them and try to make that number the same. Is that okay? So this was 1:2 earlier. We wrote that as 2:4 so that this number becomes the same in both of them. Any problems with this? Now, once we have this ratio, if the total amount is 108 grams, how many grams of paprika should be used there? It's just 2 plus 4 plus 3, which is 9 multiplied by 108. You can see what that gives you. Sorry, it was black pepper, I'm sorry. No, paprika, 3. 3 over 9 into 108, that is 36. This is the amount of paprika that you should be using. Any problem with this? No? Okay. Sometimes you can set up equations using ratios as well. For instance, if you have this ratio, y ratio 2.4, and they're saying that's equivalent to 2.7 ratio 3.6, what's the value of y? How do you figure this out? Remember, ratios can be written as fractions as well. So we can make an equation like this. We can say y over 2.4, that's the same thing as 2.7 over 3.6, and that should give you the value for y. Okay, sometimes you can make equations using ratios like this and find the values of any unknowns like that. Any problem with this? No? No problems? What's the value that we get from this? Sorry? 9/5. So this is our final result.